Hello class 11 science. Today you are going to discuss about a very and important topic, hybridization. Okay, it is a very new concept in chemistry, so we need to understand this process. Okay, so the definition tells us hybridization is the concept of intermixing of the orbitals of an atom having nearly the same energy to give exactly equivalent orbitals with same energy, identical shapes and symmetrical orientation in space. Okay, so hybridization is basically it is a concept in which we mix the orbital of an atom which have got the same energy so that it gives an equivalent amount of orbital. Say for example, if the mixing of orbital is 2, you will get two equivalent hybrid orbitals, we can say, and this hybrid orbital will have the same energy, they'll have a same shape and they orient in symmetrical way in space. So this is the definition of hybridization. Now characteristics of hybridization. First one, orbitals involved in hydrogen should have nearly the same energy. So the orbitals which are undergoing hybridization, they should have the same energy. Say for example, if you have got 1s, 2s and 2p, then 2s and 2p will undergo hybridization, the orbitals having the similar energy. The orbitals of one and the same atom participate in hybridization. So the orbitals of the same atom undergo hybridization. The number of hybrid orbitals formed is equal to the number of hybridizing orbitals. So whatever number of orbitals they are mixing, it will form the same number of hybrid orbitals, we can say. The hybrid orbitals are all equivalent in shape and energy. A hybrid orbital which is taking part in bond formation must contain one electron in it. So the hybrid orbital which is taking part in the bond formation, it must have one electron. Due to the electronic repulsions between the hybrid orbitals, they tend to remain at the maximum distance apart. So since the hybrid orbitals contain one electron, so if the electrons are present, there will be an electronic repulsion and they tend to remain the maximum distance apart, so they will repel each other, we can say. Hybridized orbitals show only head-on overlapping and thus form only sigma bond. So hybridized orbitals, they form only a sigma bond by head-on overlapping, because we have already discussed about the sigma bond. They never form pi bonds. With increase in s character, electronegativity of the atom involved in the hybridization increases. We'll come this point later on. Size of the hybrid orbital decreases with increase in s character. So we have got these three types of hybridization: sp3, sp2, sp hybridization. So the size of the hybrid orbital decreases with increase in s character. So s character means percentage of s orbital. In this sp3 we have got 25%, in sp2 we have got 33%, and in sp we have got 50%. Okay, now types of hybridization. Now we need to discuss about these types of hybridization. We have got three types of hybridization: sp3, sp2 and sp. This is the hybridization involving only s and p orbital, where we mix only s and p orbital. The geometry of sp3 hybridization is tetrahedral and the bond angle will be 109.5 degree. And the examples of such compounds is methane and ethene. Similarly, second type is sp2 hybridization, where the structure or the geometry is trigonal and the bond angle is 120 degree. And examples is ethene C2H4. Similarly, the third type is sp hybridization, where you have got one s and one p orbital. The geometry is linear and the bond angle 180 degree. And the example acetylene, or we can call ethine C2H2 and carbon dioxide. So this is the general classification of hybridization, which we need to discuss one by one. So first we are going to discuss about sp3 hybridization. Now, when one 2s orbital and three 2p orbitals of excited carbon get intermixed to form four hybrid orbitals, then these hybrid orbitals are known as sp3 hybrid orbitals. This phenomenon is called sp3 hybrid. Okay, now to understand this, let us take an example of a carbon compound. Okay, so carbon compound methane. In methane, the central atom is carbon and the carbon, as we know, is bonded to 4 other hydrogen atoms. So carbon has got atomic number 6, so the electronic configuration will be 1s2, 2s2 and 2p2. Now when you see this one, then it has got only 2 unpaired electrons, but in case of methane we have got 4 carbon hydrogen bond. So for the formation of 4 hydrogen bond we need to have 4 unpaired electrons, but over here we don't have. So what we'll do is we'll excite the 1 electron from 2s to 2p. Okay, so electron is permitted from 2s to 2p. Now if you see, the number of unpaired electrons will be 1 2 3 4. So 4 unpaired electrons, so it can form 4 bonds. Okay, now this 2s and 2p orbital, if you see unpaired electrons, so it will undergo, since in methane we have got 4 hydrogen atoms and each hydrogen have got one unpaired electron, so this 4 orbitals will be used up. This is from S and this is from P. So when they are used, it will form Sp3 hybridization, and they are now known as Sp3 hybrid orbitals. Okay, and this will remain as paid. Fine. Now the shape of one s orbital is symmetrical, spherical, we can say, px, py and pz. Now these orbitals undergo hybridization to give you Sp3 hybrid orbitals. Now since we have got 4 Sp3 hybrid orbitals, and we know the shape of that hybrid orbitals will be oriented in a tetrahedral manner, so 4 Sp3 hybrid orbitals will be oriented in this manner, tetrahedral. Okay, where the bond angle will be 109.5 degree or 109.28 degree. Now for the formation of methane, these 4 Sp3 hybrid orbitals are oriented in a tetrahedral manner, and each Sp3 hybrid orbital overlap with the hydrogen atoms. Okay, we can see 4 hydrogen atoms over there, and they have overlap with each other. So this overlap we call it a hidden overlap, and we know that hidden overlap give rise to a sigma bond. So this will result in the formation of this tetrahedral structure of methane, with bond angle will be 109.5 degree. So this is how formation of methane will take place. Similarly, for Sp2 hybridization, we'll take the example of ethene molecule. That is, I'm talking about this compound, okay, C2H4. Now in this, once again we write down the electronic configuration of carbon like this. Since we need one, since in carbon, in ethene we have got a carbon-carbon double bond, and we have got 3 sigma bonds. So for that we'll excite this electron over here. Okay, now in this case only this 1s and this 2p will be used up, since because of the 3 sigma bond. So it will and this p orbital will remain unused, unhybridized p orbital. We'll see later on what is the function for this. So when 2s orbital and 2p orbital, 2px and 2py of excited carbon atom get intermixed to form 3 hybrid orbitals, then these orbitals are known as Sp2 hybrid orbitals. This phenomenon is called Sp2 hybridization. So it will form Sp2 hybrid orbitals, and we have got 3 Sp2 hybrid orbitals. These hybrid orbitals are oriented in a trigonal manner, we can say trigonal manner. Okay, Sp2, 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 and that one unused, that is pz orbital, will remain perpendicular to the axis. Okay, now this is for the carbon number 1. In ethene we have got 2 carbon atom which have got the similar environment. So if this is for carbon number 1, similar hybrid orbitals will be formed for carbon number 2. Now this is for carbon number 1, we can say carbon number 2. So they have got the equilateral trigonal planar structure like this. This for carbon number 1 and this for carbon number 2. Now, and in case of ethene we have got 4 hydrogens, so 2 hydrogens will linked with this Sp2 hybrid orbital and 2 over here. Now this pz orbital, the pz orbital which is perpendicular to the axis, will now overlap with each other. That will give rise to a pi bond, because pi bond is formed by the sidewise overlapping of p orbital. And since and one more sigma bond is formed over here, so 1 2 3 4 5 sigma bond and y pi bond, 1 pi bond. So this is how ethene molecule is formed. Now assignment number 13. Today's assignment, question number 1, define hybridization. Write few characteristics of hybridization. Question number 2, write the different types of hybridization, mention their respective geometry and bond angles. Question number 3, what is Sp3 hybridization? Explain the formation of methane. And question number 4, what is Sp2 hybridization, and explain the formation of ethene molecule. Complete this assignment and send it in my